Hi guys, this is Mrs. Villette, and this video is going over the common mistakes made on the Unit 6 test. So the first common mistake had to do with negatives and exponents, specifically the difference between an expression like this and like this. So the first expression would be read as the opposite of the 1/2 power of 4. Notice this is not 4 and 1/2. This is actually an exponent, so I'll make that a little bit more clear. So that's a 1/2 power of 4. This expression means the 1/2 power of -4. Now the difference between these two expressions is what the exponent applies to. In the first problem, the exponent only applies to the 4. So really you should think of this problem, taking the opposite of is like taking -1 times something. So I'm taking -1 times 4 to the 1/2. Now order of operation says do the exponent first and then the multiplication. So the exponent first means I'm doing the square root of 4, that's what a 1/2 power means, and then multiplying that answer by -1. So in the end I get -2. However, on this problem, the 1/2 power is applying to the -4. Even if we apply this idea of multiplying by -1, well then exponent rules would say I need to do -1 to the 1/2 times 4 to the 1/2. So that would be the square root of -1 times the square root of 4. Now we know that the square root of -1 is not real, so you could write I though. Square root of -1 is I times 2, so your answer here would be 2I. Now of the choices you had on the multiple choice, you would have chosen not a real number, but in other contexts, you would simplify that to 2I. So the second misconception had to do with transformations where there was a horizontal shift and a reflection. And in particular, we were doing reflections over the y-axis and then a shift. So let's say you were given a picture that looked something like this, and this point was at 6, 0. You were supposed to come up with the answer for that graph. Well, there is a vertical, there is a horizontal reflection, so it has been flipped over the y-axis relative to our parent function. So our parent function looks like this, y equals square root of x. So it's been flipped and then it's also been shifted. So maybe you were confronted with answer choices that looked like this. And all of these answers seem reasonable in some way or another. So let's start with A. So A has some sort of reflection, and it has some sort of shift. Right now that looks like it might be a shift to the right, but I'm not really sure. B has a reflection and also a shift. I don't really know if it's right or left. This one actually maybe looks like it was left. And this one also has a reflection and definitely a shift right. I can tell here that this one has a shift right. So the key here first is to identify what type of reflection you have. I have a reflection where this function has been flipped around the y-axis. Now even though it's been flipped around the y-axis, the x values have changed, and so that has to be something that happened on the inside of the parentheses. So that eliminates C because this is actually a vertical reflection, or a reflection over x. Okay, so now we're down to our other two choices. One strategy that you could employ is to actually plug in this ordered pair that you know and see what happens. So if I plug 6 into the y value, no, that's not what I want to do. If I plug 0 into the y value and 6 into the x, I get 0 equals the square root of 0, which is true. So far that one's looking pretty good. If I plug 0 into the y and 6 into the x, I get 0 equals the square root of -12. That doesn't work. So clearly just by a process of elimination, if those are my only choices, I'm going to select this option A. So let's try to figure out why option A is the right answer. Whenever we have a horizontal compression or stretch, you always want to factor that out. So always factor out a horizontal stretch, compression, reflection. So if I was thinking about this problem, I would say, okay, it's shifted to the right 6. I know that that looks like the square root of x minus 6. And there is also a reflection. Now if I look at what that simplifies to algebraically, if I distribute, that's a negative x plus 6, so that matches A. Okay, the next type of problem had to do with simplifying and rationalizing denominators. So everybody had some sort of expression where you had a radical in the bottom and then you had 2 radicals subtracted in the top. So these are not the examples you were given, but this is a similar structure to the problem. And the instructions said to rationalize, simplify, including rationalizing. So the first thing I'm going to do is work on breaking down some of these roots. So for example, root of 72. I can think of 72 as 8 times 9, and I can think of 8 as 2 times 4, 4 as 2 times 2, and then 9 as 3 times 3. So 72 is actually 2 cubed times 3 squared, but I'm looking for square roots, so maybe it's better for me to think about it as 2 squared times 3 squared times 2. Really, that 2 squared times 3 squared was a 36, so had you first started breaking down 72 as 36 and 2, that would have been faster. So I can write my denominator as the square root of 36 and the square root of 2. Same idea with 32. If you recognize 32 is 16 times 2, then you can do square root of 16, square root of 2. And then 50 is 25 and 2. So 50 would be 3 square root of 25 square root of 2. Okay, so now I actually do my square roots that I can. So 4 square root of 2, subtract 3 times 5 square root of 2, all over 6 square root of 2. Or 4 square root of 2, subtract 15 square root of 2, all over 6 square root of 2. Now the numerators are like terms, so I can combine them. I can say this is negative 11 square root of 2 over 6 square root of 2. What I did when I combined those was I subtracted the coefficients. They are like radicals. Now in this case, I don't actually have to rationalize just because of the particular problems I came up with, because I can just cancel those square roots of 2. So let's look at another situation. Let's pretend you've already done this step. You've gotten to a single radical in the numerator. So let's say you ended up with negative 11 square root of 2, but it was over 5 square root of 3. Let's actually make it a little bit different. I'm changing up the problem a little bit just to give you some more examples of how the simplifying could work. So I have negative 12 square root of 2 over 5 square root of 3. So I can't just square this thing to get rid of the radical in the denominator. I need to multiply by something so that my denominator no longer has a square root. And the only thing I'm allowed to multiply by is a 1. I can add a 0, I can multiply by a 1. The one that I want to choose to multiply by is the square root of 3 over the square root of 3. Why do I want to do that? Well, now my denominator is 5 times the square root of 9, and I can take the square root of 9. My numerator is negative 12 times the square root of 6. Can't take the square root of 6. This becomes negative 12 square root of 6 all over 15, because I'm going to take the square root of 9, which is 3, multiply it with 5 and get 15. Now we're not done yet, because this 12 and the 15, those coefficients, are both divisible by 3. So if I divide by 3, I get 4 and 5. So my final answer is negative 4 square root of 6 over 5, or you could write that as negative 4/5 times the root of 6, and those would be equivalent forms. So those are the types of questions that you will see show up on your multiple choice assessment. They will not be the same questions as your test, and they may not be worded in exactly the same way. They will be testing you on those same concepts that were on those problems from your test.